Hi, I'm Xavier de Kestelier. I'm an architect at Hassell Studio. Welcome to Hassell Talks. As an architect over the last year or so, I got involved in quite a very special project. It was actually a competition for NASA. And the brief of the competition was to design a habitat for 4 astronauts on Mars. What kind of place would these 4 first astronauts on Mars, how would they live? What would that place look like? Now, once you start a competition like that as an architect, we needed quite a lot of info and data. How is it? How would it be to live on Mars? So we started to call around, and all roads seemed to lead to this one person that I didn't meet yet. This guy called Professor Sanjeev Gupta. Everybody told me, talk to Sanjeev. He'll be able to help you out. So, of course, what I did, I emailed Professor Sanjeev Gupta. And Sanjeev, you're here with us now today.
I know, it's great. Thanks.
Thank you so much for being here. And the amazing thing what happened when I asked Sanjeev, look, I'm going to organize a little symposium. And the idea of the symposium is to get as much as information as possible and people to come together, scientists, engineers, to come and critique our little proposal, right? But Sanjeev, you never made it to my symposium. Can you explain why?
I was actually going to quite an important meeting where we were discussing the proposed landing site for one of the future rovers, the European rover, actually. So I couldn't miss that because I was chairing the meeting. So sorry, Javier.
So you were doing actual Mars work for real stuff, going to Mars. Okay, I think that's a good excuse. Now, Sanjeev, I'd love to hear more about your professor of geology and Mars science. How did you got into this field? Was this something that you, as a child, you wanted to do? You wanted to get into this field, or tell me more about it?
No. I had no interest whatsoever in planetary science. It was an accident, actually. As most good things are, they're accidents. You just pursue things that you find randomly. So actually, I blame my Mars interest on my kids, actually, because when I got into this, they were quite young. And I'm a field geologist. So I've been trained to go out into the field. I go out to the places like the Himalaya and Tibet and desert areas. But with them being young, I couldn't go and do field work, and I was kind of watching my career nosedive, basically, and was ready to quit and go and find something else to do. And then realized, actually, I was at a conference and I saw talk about Mars, and I thought, and there were just amazing data sets coming from orbiters and satellites going around Mars. And so I basically thought, I could actually do this from home. So I spent about a year. I just shut myself off. My managers were not very happy because I wasn't bringing in money or writing papers or anything, all these things that academics are supposed to do. But I just spent a year and a half just reading everything about Mars.
And just learning.
Just learning, because I think you can't enter a new field without having that deep knowledge. Otherwise, you look like an idiot, basically. Mm-hmm. And so I did that. Wrote some proposals. They all got rejected. They all said, Sanjeev, you're not a planetary scientist. You can't possibly do this. But
you don't belong here.
You don't belong here. You don't belong here, basically. I was told I don't belong here. And about the 4th go, they actually funded me. And I got into it. And that's how I got into it. So I'm still an interloper.
Yeah, which is a good position to be in. You kind of, when I asked you what you actually do with NASA, because you work with NASA at the moment, and I always tell my friends, I know the guy that drives the Mars rover. I know it's not 100% accurate, but for me, it's kind of close. Could you tell me what you really do with the current Mars mission?
Okay, so it's 100% inaccurate. Nobody would ever let me near a Mars rover. I am a bad driver. And actually, to be honest, driving a Mars rover is actually down, because basically all it involves is writing code. I'm not very interested in writing code. Other people are, but that's so what I do is I have 2 roles. So I work on the NASA Mars Science Laboratory, the Curiosity rover, and I have 2 roles on that. So firstly, I'm a scientist, so I look at the images that the rover collects, and I ask the rover to collect images. that I analyze the geology of. So I look at the rocks, and my job is to reconstruct what the ancient landscape on Mars was like. So we know what the landscape in present-day Mars is like, but I can look into those pictures and sort of try and work out if Mars was warm and wet in the past. And secondly, I have an operations role, which is I'm a strategic planner for the mission. So one of 8 people. We're kind of the brains trust for the rover. So actually today, I am responsible for the rover. So after this recording, I will go back home to my armchair and I will plan what the rover will be doing.
And tell me, how do you plan that? What are the tools that you have to plan something like that?
So it's interesting. It's a large team. And so what I will be doing is working closely with the engineers in thinking about what experiments we want to do on Mars. We're actually finishing up a set of experiments, so we're just making sure that we've ticked all the boxes, etc. So it's about 8 hours on a telephone. That's what it is. We're on a telecon for 8 hours, multiple meetings. We have all sorts of tools where we can look at data. We have chat rooms where we can discuss things with multiple people, etc.
And do you see what the Mars rover sees at the moment, or how does that?
No, so we don't work real time. So we have data that came down yesterday. So there's no video link or anything like that, but we have data that came down yesterday, so we know where we are, and we can think about what we want to do. But actually, the main item on the Mars rover dinner tonight is actually we are planning something quite exciting in the next few days, and we have to reach a consensus in the team as to whether we want to do it. Actually, so we're up against a little cliff face, not a big cliff face, but a little cliff face, and we want to actually drive up over the rock face and onto the flat piece of rock, and it's a little bit tricky. It's probably the hardest thing we've ever done, actually.
All right, we're driving how to move it.
And we're basically going to have a discussion which I've got to coordinate. So in a sense, I'm a facilitator in sort of looking at the different arguments. And what we do is we work as a team. So probably I will be convening a meeting of about 100 people by telephone.
Great.
And trying to. Some people will be saying, yeah, we need to do this. This is really important. And other people are saying, no, it's not that important. We need to go and do something else. And you've got to try and find the balance between that. And we work as a team. So there's nobody we don't have a CEO who says, no, we're doing that. So it's.
Sanjeev, what are the biggest piece of research that you've done, or what stuff have you found out in the last few years with the Mars rover?
So I think we send rovers to Mars really to look for evidence for life. That's what people are interested in. That's the big sort of fundamental science goal for these missions to Mars. I mean, there's no riches on Mars. There's only scientific riches. And so before we can actually discover life, I think that's a really hard ask. What we're first interested in were the conditions on ancient Mars. So this is going back billions of years. We don't think life is present on Mars at the present day. So we're looking at rocks from billions of years ago, hunting for evidence for life. And what we want to know is, were those rocks the right sort of conditions for life to have formed and lived in and evolved in? And so it's all about what we call habitability. Was Mars a habitable planet? And so the big results really of the Curiosity mission that have been the game changers, if you like, have been that we've discovered that the place that Curiosity is exploring, Gale Crater, had really habitable environments. So there were.
So what would it have looked like?
Would have been rivers. There would have been likely rainfall or snowfall falling on the mountains of the crater rim. This would have melted, and there would have been rivers. And all the water in that river would have been transported into lakes. And so we have clear evidence for lakes that existed, and that probably lasted for hundreds of thousands, if not millions of years. I think that's been the headline news, really. And then secondly, we have an instrument on the rover that looks for organic matter as a precursor for life. And we have made the discovery of organic matter in those rocks.
But that doesn't mean automatically life.
No, it doesn't mean. So organic matter can be formed abiotically, so without biology. And we actually think that this organic matter was actually delivered to Mars from meteorites, and meteorites contain organic matter. I think what's exciting about that is that we can actually, with a robot, actually discover the presence of organic matter on Mars. And that gives us great hope that with better instrumentation, better rovers, or even bringing samples back to Earth, we can actually discover.
Because we've never
life.
done that, right?
No, so
all
we've
the
not.
samples, all the tests, all happen on
Yeah,
Mars.
so we don't have samples from Mars.
So me as an architect, I'm of course interested in humans, being on Mars, because that's what the project was about. And as an architect, you design for humans. What are your thoughts on that? You are doing experiments with the rover. Do you think there is actually a need for humans to go to Mars?
So I think there's two parts of this. Firstly, I think we will just go. And it's because essentially Mars is really the only place that humans can go to in the solar system. Beyond that, it's impossible, really, in our current thinking. So I think
is that because all the other planets are just inhabitable?
Well, we can't go to Venus. You want to go to Venus, and then we might eventually get to the outer moons, to the moons of the outer planets. But I think that's very unlikely at the moment. So I think really Mars, they're too far, and it's it's too difficult and complex and etc. But Mars is actually tangible. It's doable. So I think we'll go because it's a target for us. Humans have always explored, and so we will just go. Somebody will go. But really, scientifically, I think something that people forget is that we will go to Mars really for science. Those are the riches, the scientific riches to be uncovered.
It's not for mining or anything like that?
Not really, no. I don't think we'll do that. But I think it's for scientific riches, really to solve this problem. Are we alone in the universe, or did life arise elsewhere? And the problem with robots is that it's actually very hard to do our science. To give you an example, I think we sort of think that what a robot takes maybe 3 to 4 days to do, if I was an astronaut on Mars, I could do in 30 minutes. So so
much more effective.
Much more effective we have. Obviously, there's a huge team behind a robot, but we have to command it. There's a time delay.
So how many people are there on
the Curiosity mission has 400 scientists and 200 engineers.
Wow!
Working
just for the one rover and all the science experiments.
That's right. Yeah, that's it. It requires an enormous amount of because we work every day. You can't work every day; you'd go mad. So it requires enormous effort and huge amounts of different expertise, etc. The problem is obviously a robot, when it's on Mars, can't actually decide by itself what to do. So there's this whole sort of time delay between making decisions. And then it obviously can't go everywhere. It's limited. Curiosity is a big rover. It's the size of a Mini Cooper. And for geologists, all the exciting things happen in dangerous areas. There's cliff faces, etc. So there are many, many places we can't actually get to. And that's often where the exciting geology is, where we can actually see things. And so having, when I'm in the field doing geology, looking at rocks, just imagine you being down on the Dorset coast, for example, walking along a beach and you see these cliff faces and you can go up to the cliff face and there's pebbles everywhere. You can't imagine a rover driving there. So us geologists, we like to get up close and personal with the rocks. We like to get our eyes right up to them and etc. and touch them and etc. But we need basically, we have to make a lot of decisions. There's a lot of rock on Mars too, and we have to make a lot of decisions about, should we look at this rock or should we look at that rock? Should we sample this one or should we sample that one? Using a robot, it takes enormous amount of time, whereas a geologist, an astronaut geologist on Mars could make those instantaneously. So humans have this cognitive ability.
So if you were that astronaut-stroke geologist going to Mars, and I think even on the moon, there was only one scientist that ever stepped on the moon. The other ones were military backgrounds. Those astronauts in the Apollo era. How would you go about as geologists in that landscape? And I think I just kind of recall some conversations we had, how you as a geologist, how you operate on Earth, how you go and take in the landscape almost. Can you talk a bit more about that?
So I'm probably quite a lazy geologist. So the first thing that I do, I always carry a flask of coffee with me, is that actually get to a relatively high vantage point and I gaze across the scenery just to put myself in that landscape. It's really important to put yourself in the landscape. And the key thing is that you can't just collect data. You actually have to make your interpretations somewhat in the field. So I sort of put myself in that landscape and I try and work out exactly what I want to do. I develop a strategy for what I want to do. It's probably a little bit similar to you as an architect when you're visiting a developing site where you're thinking about.
Yeah, I think absolutely. I think as an architect or an urbanist or anybody that works in urban environment, what we need to do is go there, you know. And I remember as a student, even the first time you were given a site, I remember our professors going, you have to go there every single day and different times of the day just to kind of take it all in. I think we still do that. You know, once we have a site, the best thing to do is go and sit there, look at people, how they use the urban space, what they do, what they look at, what they're interested in, what they're interacting with, what they aren't interacting with. So I think that's really, really important. Just be in the landscape, be in the environment, right?
And actually, you know, one of the things that maybe will surprise you, but actually what I do is when I'm in that landscape, the first thing that I do is I draw sketches. I have a sketch pad. I have an A3 sketch pad that I carry and I draw the landscape and I draw the rocks and it helps me focus and think about what I'm seeing. That way I can actually design the strategy of how I'm going to interrogate this landscape, because I need to interrogate it to reconstruct what happened. What I'm trying to do is to replay what that landscape or the rocks in the landscape looked like in the past, but you can't suddenly approach them and say, tell me what you are, tell me what's going on. No, you have to be a bit more subtle about it. And that requires asking questions. So I actually sit down, I'm drawing, I'm asking questions, I'm thinking about, should I do this? Should I do that?
So, Sanjeev, you use words like design and ask questions and you sketch. You're almost like an architect, right?
Yeah, sometimes.
Is the tools that we as architects and designers use?
Well, funnily enough, my daughter says that I'm not really a scientist sometimes because she thinks what I'm doing is quite bizarre. Yeah, there's different forms of scientists, but geology is actually requires a bit of an artistic bent, actually, because the data doesn't immediately speak out. What I'm trying to do is I'm trying to reconstruct a narrative of the Earth and Mars, basically, and that story is not easy to read, basically. So I'm a little bit like a historian, where I've got all these archives with missing pages, etc., and I'm using those missing pages to reconstruct what happened in between and to create a chronology of events and etc. So it is. I always actually wanted to be a historian, and my parents didn't. You're not going to make any money being a historian, so I became a geologist instead. Not that you make any money.
No, exactly. So I just find it really fascinating. You know, you're a scientist using some actually quite design and architectural tools in your thinking, and I'm an architect, and I'm quite obsessed by science and engineering. I love to kind of use lots of data in our design, because that really, for me, gives me a good kind of handle, a good grip on the world. And, you know, I love to design with data and facts, and not just architecture as an artistic expression. Right? Of course, it is always an artistic expression, but if it's like embedded within science and engineering, but I think, so much better.
Yeah, but I think actually the scientific endeavor, I think people don't really realize, is actually very similar. It's not just hard facts and hard data. You have to develop a story. And there's a little bit of certainly in geology, there's a bit of a gap between the data. You can't immediately jump to an interpretation. It does require a bit of an artistic mind in developing that.
I start to feel like both of us are not really trying to be confined by our own fields. You know, we try to get out of that bubble, myself out of what architecture is supposed to be, because I'm designing stuff on Mars. Talking to scientists and engineers a lot, and you are a scientist that actually is quite interested in architecture and artistic expression. And I think in one of your TEDx talks, you talk about you'd be quite interested in what the first piece of art or the first artist would do on Mars. What would he be doing?
Oh, they'd be doing beautiful landscape paintings. I think it's if you think about it, in the explorations of the 16th, 17th centuries, they always had artists going along painting the landscapes that they discovered. Mm-hmm. And I would hope that human missions to Mars would actually, in addition to the scientists and the geologists mm-hmm. and the biologists, they would actually take artists along and to record. Because whilst we can take pictures, there's just something about that ability to sketch and paint that captures the imagination in a way that a photograph doesn't necessarily do.
I just thought of that question myself, and I want to see what your thoughts on that are. Because, in our proposal for the Mars habitat, we bring a whole bunch of robotic rovers with us, autonomous rovers. Always send them actually first, years in advance, to start building a shell structure that would protect us from very harmful gamma radiation on the Martian surface. And I always had this idea, well, what am I going to do with these robots once they've finished their job? And one of the kind of fantasies I had, well, maybe some of our astronauts, they might start using them to do some amazing land art on Mars. How do you feel about that? Actually, not just capturing Mars, but actually starting to change it. As a geologist,
I was not sure about that. Actually, I think maybe in a confined space, and not initially, perhaps, because I think we're going to a pristine landscape, and we'd want to preserve that landscape and not put that
because whatever we do is
whatever we do, we already have, because every time we send a robot down there, there's all this debris. I mean, my son always accuses me of environmentally damaging Mars. There's lots of debris, there's parachute shells and bits of spacecraft, but obviously they're confined. That kind of interesting. We'd get this landscape art, like Richard Long, for example, etc. Would be quite interesting to see what one could do. I mean, even as scientists, we're very fascinated by, for example, quite often one of the orbiters takes the HiRISE camera on the Mars Reconnaissance Orbiter, takes pictures of the rover.
And right. So you actually does.
Yeah, so we can actually see this. And for us, it's really amazing to see the rover, and you can see the wheel tracks. And you can actually track our route through the Martian landscape. And it's amazing to see that that's actually, and sometimes one of the most compelling images that we have from Curiosity is when, again, we did something quite dangerous. In the end, it wasn't that dangerous, but we were worried about it. We had to cross a dune, and the rover driver suggested we take a picture just looking back at the rover tracks. Okay. We didn't really think much of it. And the image that's come back, it's just totally compelling. In fact, we're going to use it for an exhibition because you just see this extraordinary little landscape of this dune and this curved rover tracks crossing this. And it gives you a sense of, that journey. It gives you a sense of journey. But, in a sense, there's an artistic impression, if you like. Accidental, so it's not artistic, but there's something about that image. So we don't take the images for an artistic purpose, but they have something to them, a quality to them that, and we often think about images in an artistic way. Actually, the first thing we think about is not about the science value of an image, but often people will look at an image and think, that looks aesthetically pleasing in some sort of way. So Xavier, tell me, now know how I got involved in Mars completely accidentally, but tell me how you got involved.
Oh gosh, it goes quite a while back. As a young kid, I was really fascinated by space, and I must have been about how old was I? Probably 13 years old. And my dad took me to an exhibition in Brussels. I grew up in Ghent, in Belgium. And the exhibition, it was kind of it's probably by the end of the Cold War, I think, back then. And the exhibition was on space. And they had the Russian Space Agency sent stuff over, NASA sent stuff over. And I wasn't really impressed by the NASA stuff because they sent up a really big blow-up space shuttle. Wasn't that impressed by it. But the Russians, they sent the Mir training module.
Oh, wow.
And I was just completely blown away by it because at that point, Mir was in orbit, going around us, and the exact same copy was standing there in front of me. I was able to walk in, I was able to touch everything, right? And I thought it just literally blew my mind, right? That I was in the same space as was up there in orbit. And I remember going back home, and the first thing I did is I kind of nicked my sister's rapidograph pens and A3 drawing board, and I started, which she was studying geography at university back then. So I took it and I started make drawings of spaceships, but they weren't sci-fi style spaceships. No, they were kind of accurate, or as accurate as possible as I could, drawings of spaceships. And they weren't perspectives, they were actually sections I drew, like an architectural section. With all the wires and like the MNEs, everything was in there.
So you actually became a space architect before you became a...
I think so, right? Anyway, that drawing is still somewhere at my parents' house. I haven't found it back. I need to find it at some point. And I never thought I could become something to do in space. Belgium doesn't really have a space agency, so I didn't really think about it. I did become an architect. And then years later, while I was working at Foster & Partners, I got in contact with somebody, Enrico Dini from Italy, who was at that point making the world's first large-scale 3D printer. European Space Agency saw what he was doing. They wanted to do some research with him, but it's like, you better team up with somebody, the bigger firm. He knew me. We teamed up. And that was the first time we got into doing some research for Space Agency, looking at habitats. ESA was a bit confused why we were there in the research team. What are these architects going to do? Right? Didn't really understand it. But then they saw the output, and what we did was we gave a kind of a vision, a quite holistic vision of what it could be to live on the moon, right? And I think it was very different to what they normally expect, because their research questions are very engineering-led.
Yeah, I don't think they involve any design, do they?
No, they don't. And it's very, very specific, right? Do this, that, and that, and it's solve a very particular question. But they never have an overall vision, right? Or there might be written down vision, but there's no visuals for that or worked out visuals. So we decided to somehow play this role where we said, okay, we're architects, we don't know enough. We're not the engineers or the scientists, so we can't go into that much detail. But we are much better than what space agencies normally call the artist impression, which is a little bit of fantasy often, right? So we thought, well, what we do is we're somewhere in the middle. We're able to give that overall vision, that visual, but it's really grounded in science and engineering. So although we haven't solved everything yet, so we found ourselves in this kind of role, this kind of middle of the road role, almost being embedded in science and engineering, but also giving an overall vision.
That's pretty cool, actually.
That's how I got into space. We've done a few projects, one on the moon, and I've done a couple of now on Mars. And hopefully, I think we can start to convince space agencies that as a designer, we have a crucial role to play in space development.
Yeah, I think so. And I think it's, as a scientist, I've not really thought of that, but I have been involved in recent years in actually thinking about some of the first landing sites where humans might actually go to. And that's been fascinating. It's fascinating that we're already thinking about that, but, at the end of the day, we're actually going to Mars to do science. and probably the big science we're actually going to do is geology, habitability, what Mars was like early in its history, and the search for life. And, I went to a conference and presented my landing site, my proposed landing site.
So where are we going to land?
So my proposed landing site is a place called Hypanis, which bizarrely enough is the old Greek name for an ancient river in India where I grew up. Really bizarre. That hadn't been chosen for that reason, but actually Hypanis. No. The name had already been given. So Hypanis is actually an ancient valley which feeds a feature that on orbital images looks very much like a delta. And obviously deltas are formed where rivers feed into a standing body of water. But this one is really bizarre because it's a place where there's no enclosure, so it's not a lake. And so the idea is that this is actually, and it's one of the big hypotheses, grand hypotheses in Mars science, unsolved, is did Mars once have an ancient ocean that filled what's called the northern lowlands, so that the northern third of Mars was once an ancient ocean.
Well, a complete ocean.
Complete ocean. Wow. And, it's hotly disputed. So some people say absolutely not. Other people say, yes, the evidence is clear, and I'm kind of in the middle, maybe small C's. Anyway, we could test this by going there. And so, what you need to have is, what we do in this exploration zone is we have obviously the landing site, and then around that we have defined regions of interest, we call them. So there's scientific regions of interest where are key targets where we would actually be able to test different hypotheses about Mars science and search for life and search for the early history of Mars. But also we have engineering regions of interest. And those are really because any human expedition to Mars would have to be self-sustaining.
Yeah, so what do we need as a human?
We obviously need oxygen to breathe. We need water, and we can't take that with us. And we need oxygen, obviously, as rocket fuel to bring those humans back. So, certainly space agencies will not want to send astronauts on a one-way mission. And frankly, as a scientist, I want the rocks back.
Got some self-interest.
So there's a bit of self-interest there. So it's not like this Mars one-way journey. And so actually what we need is resources. We actually need to mine resources on Mars. And that's geology too. So actually, not only are we looking at the geology for a scientific purpose to tease out Mars's secrets, but actually we need the geology to work out how to get water and oxygen. And so
to be able to survive.
So, we could extract oxygen from the atmosphere. It's possible from Mars as a carbon dioxide rich atmosphere, extract that from there. Alternatively, there are abundant deposits of clay minerals, and clay minerals are rich in water. Attached, and so we could actually break that down and extract the water out of that, and then break the water to extract oxygen from that. So there's all sorts of ways, but we would actually have to mine those resources. And so the maps we were producing actually had all of these targets for where we would actually resource.
And would that need to happen before the astronauts go to Mars, or is that?
Well, we need to define those, and then I think, who knows? It's a long way ahead, but people are not thinking about humans going to Mars until the 2050s, probably.
Is that how you think? How long it's going to take? Because Elon Musk seems to want to go earlier, right?
Yeah. I think for having a group of astronauts who actually do science, I think you're talking about expeditions for 6 months to several years. We went to the moon for a few days. It can't do that with Mars. And so we want to get good science out of it. So, they're going to need habitations.
Yeah, I think in our proposal, which we worked with Cranfield University, our timeline actually is somewhere in the 2030s and our whole mission would probably last about 12 years from the first launches to then get stuff to Mars, to start building, constructing, and then get the astronauts there, mission and then back. It takes a long time to do something like that.
Yeah.
Sanjeev, this is a question I always get working on a project on Mars. And the question is, should we really go? Should we spend all that money, effort, knowledge in actually going there? Should we not just fix our own planet first? What is? I've got my own answer for that one, but what is your answer to it?
That's quite an interesting question. I have lots of debates, arguments with people over this. I actually don't think we get to choose. I think somebody will just do it.
Yeah.
And either a private company will do it or a nation will do it, and the other nations will quickly follow.
Mm-hmm.
I mean, and I think there's no riches out there, but it's that the scientific riches, it's that the credentials you would get and that exploration side of it. I think in doing so, it is a lot of money, but we spend a lot of money on many other things. But I think there's something aspirational about it. So it's very interesting. I do a lot of talks in schools, and I have to say, part of my career and what I do, I divide the work I do. So part of my work, my Mars work, is only 50% of my work. I actually spend a lot of time. People don't really know this, working on water resources. So I work on water resources, groundwater, sustainability, etc. in India. Nobody wants to hear about that stuff. It's because it's about problems. Yeah. We just need to do it. And we do detailed data analysis. We collect data in the field in India. We're looking at water resources for farmers. But I'll tell you what, nobody ever wants to hear about that.
Well, I do want to hear about it.
But
tell me more.
Even it was really funny. I was in India. I was running a workshop in India with the Central Groundwater Board, and they didn't want me to give a talk about groundwater. They wanted to hear a talk about Mars. And so there's something aspirational. And when you go out to schools, you can't just impose the world's problems on kids. Otherwise, it just gets never-ending depressive. It's just bad stuff. There has to be something positive, something to look forward to. And I would say that in doing these grand challenges, in technology required to be able to do this, we actually invent lots of things. And we train a lot of people. NASA, JPL, Jet Propulsion Laboratory, has a lot of engineers. They don't stay there forever. Yeah. And engineers, they'll do some stuff, designing clever things for rovers, process engineering, all sorts of things. They go on to other careers. And
it just seeps through in other areas. It seeps
through. So I think at the end of the day, most of the money is actually not in the hardware. It's actually in the salaries of clever people. Yeah. And they will go off and do other things with the knowledge and skills they gain from doing that. And so that's the important thing. So I don't think it's wasted money. And actually, probably in the grand scheme of things, if you think about it, the European rover paid for across, ExoMars rover paid for across Europe is costing something like 3 billion euros. Which seems like quite a lot of money. But if you think about the costs of infrastructure, I mean, a classic example is HS2.
Yeah,
in the UK. And
how much was that?
I mean, they're talking about 100 billion.
Yes, exactly.
I mean, obviously that's a needed project. Yeah. We need fast rail links, but that's an exorbitant cost given space missions. So I think space missions are actually not that expensive.
Well, when I get the same question, for me, I had a debate. I think it was a few weeks ago here in London, and I put the question back. Well, I think we need to go first of all for science. Right, so I don't think we're all going to mass migrate to Mars in the next 100 years because the environment is so harsh, right? Yeah. What is it, -50, -70, dust storms, and let's not talk about the gamma radiation that will, is so harmful. So for me, it's not about the mass migration, because it's not a binary thing. It's not, yes, we all go, we don't go. I often just compare it to science that happens on Antarctica, right? We have missions there. We have labs there. It doesn't mean that everybody now wants to go and live on Antarctica. Yeah. Of course not. So the other thing I then often ask is, well, how much does the Large Hadron Collider cost? And that's like fundamental research that we don't know what will come out of it, but we just do it because we are humans and we do science, and that's what makes us different, right?
Yeah, we're curious and we want to learn about the universe we live in.
So Sanjeev, thank you so much for having this chat. Learned quite a lot about Mars and science doing there, but what I really enjoyed is trying to seeing how you try to go outside your normal bubble, your normal science bubble, and that's something what me as an architect and as architects try to do as well. So thanks, Ivan, for being here for the fantastic chat.
Thanks, pleasure.
I'm Xavier de Kestelier. You've been listening to an episode of Hassell Talks, recorded here in London. If you enjoyed this conversation and would like to hear more, please subscribe and check out our other episodes. You can find us on iTunes, Spotify, Google Podcasts, and SoundCloud. Thanks for listening.